Welcome, everyone, and thank you for joining us today. My name is Paul Donahue, and I will be your host. We ask that you please keep your device muted during the session, and if you have questions, please direct them to me via the chat feature. We'll do our best to answer them at the end of the session and to follow up with any unanswered questions via email. As I think you know, these tech talks have been designed to share straightforward insights into radio frequency components, the related technology, and the extra design and engineering value that a custom manufacturer such as Quantic TRM can add. To begin today's session, I'm happy to once again introduce Quantic TRM's Chief Technology Officer, Shaun Moore. The author of 2 U.S. patents and a number of white papers and technical articles on passive microwave technologies, Shaun has been with the company since the early 90s, and his passion for helping to resolve customer problems has only grown over year from year. So, Shaun, welcome. Can you share an overview of today's topic and your objectives for the session?
Yeah, thank you, Paul. Happy to. So today we're going to talk about, surface mount components. And really, we're going to start off by saying, what is a surface mount component? Talk about some design challenges, and then some manufacturing challenges. Talk about different types of surface mount components, because all surface mount components are not the same. Move into some Quantic TRM differentiators and wrap it up with a summary.
Very good. So to get started, what exactly is surface mount?
Okay, so a surface mount component is a separate RF component that can be directly connected to another circuit board, and it's usually circuit boards in particular. So rather than actually integrating a passive component directly into the main carrier PCB, these are devices that are built separately, but yet can be mounted on a device directly without having any sort of RF connector or a cable connecting into it. So these are typically devices now that have some kind of pin sticking out of them, or some sort of another interface where you can actually have the RF connections with some sort of a direct connect. Usually a direct solder interconnections are how these are done. What does this actually do? Well, it goes through there. It actually modifies the way we're mechanically interfacing between the subcomponent and the main circuit. But that's really what a surface mount component is. And what sort of parts can we make surface mount? Well, in theory, we can make anything a surface mount. If there's a separate device right now that has some sort of interface, that interface can be redesigned so that there is a direct connection. There are trade-offs in doing that, whether it's size, weight, performance, how it's mounted. Some RF components are so large that it doesn't make any sense to go ahead and do a direct sort of mount. Other times, environmental conditions will preclude it, whether it's vibration because of mass or whatever else. These are all things that have to be taken into account. But essentially, most parts can be made surface mount if the other criteria make sense.
Okay. And what are some of the technology design challenges that you had that listed on the overview page?
Sure. So the really, I think keep in mind here is that a surface mounted part is not the exact same part without connectors. It is similar to that, but it really isn't the same part. The housing for most RF components does play a bigger role in the component design than just supplying a carrier. And I think that is a sort of a mental leap that needs to happen, is that most housings are indeed part of the RF circuit, and by eliminating the housings, you are therefore modifying the way that the circuit is being designed. Also, if you were to go in there and just remove the connectors and have a pin sticking out of the housing, you would realize very quickly that the carrier PCB would more than likely be inadequate to be able to support those sorts of devices because of the size and weight of the housing. So really, if you take a look at how that actually works out, then you have to work out how we're actually going to connect the device over to the main PCB. Or we're going to solder down, direct down, or we're going to have screws holding it down. You know, what's the mechanism for mechanically holding it in place? As we're making that decision, we have to look at whether or not this device is going to be able to survive high vibration. If the device is large, whether or not the coefficient of thermal expansion, or CTE, will align and still have a reliable interconnection or solder joint. Sometimes very large parts have difficulty if there are large differences in the thermal coefficient of expansion. Make sure we still have a reliable solder joint. Something else also to consider is that if we have a direct solder connection, we need to make sure we still have a 50 ohm interface between the components. The nice thing about connectors is they are nice 50 ohm devices, and they are in a standard TEM mode, and they transmit energy quite nicely. As soon as you go into a pin sort of interface, you can very easily disrupt that mode, which can cause other performance issues. From a technology standpoint, we can certainly build surface mount components either using distributed technology, which is really a way of saying multi-layer PCBs with a distributed kind of a circuit within there. We can also use lumped elements as well on an individual card that has a soldered interface with a direct connection, which I'll be showing you an example of that a little bit later on. Also, how can we actually package these parts? Well, we can have a lumped element circuit that's covered. We can have a lumped element circuit that's open. We can have bonded PCBs. There's just a couple of examples of the types of circuits we can actually end up with. And do we want to put the device on a tape and reel for an automatic insertion? For a pick and place machine. These are all things that we need to consider with what it is that we really want or need for the device to be able to do.
You also mentioned, Shaun, that there are different surface mount styles. Can you elaborate?
Sure. So really, I think if you take a look at the couple of pictures here, you see the couple of different styles of, and these are kind of the popular ones. So the lumped element open circuit one is the one that's sort of in the middle on the top. That there essentially has usually for lower frequency sort of components. We have that PCB gets directly soldered down to its to the main PCB. This sort of circuit here is it's essentially taking almost like a daughter card approach to being able to build that. There is no connections between there. All the way on the right-hand side of the page there, you'll see that flat pack sort of package. That contains lumped elements inside of it, but it's a sealed package, and therefore you can then now take that and direct solder that down onto your PCB. Again, that's sort of a halfway point between a connectorized part and a surface mount part. The bonded multi-layer parts, which are the other two photos on the page, really show what are commonly moving to more industry sort of components here, where the entire circuit is embedded in this multi-layer PCB, and the interconnections are done through exposed plated through options on the edge of the PCB. So the interconnection is done by soldering directly down to these plated structures along the edge of the PCB.
Okay, so you had mentioned some of the technology design challenges. I gather there's also manufacturing design challenges associated with surface mount products.
Well, there is, and really depending on the type of technology that you're looking for, there are different challenges. I'll start with the bonded multi-layer PCB. That one over there, we do have some downfalls there in the fact that if we're looking at a couple line structure inside that multi-layer PCB, those coupled line structures are fully embedded in the PCB, and there's no way to go in there and adjust for any manufacturing variability. Therefore, we end up with some yield problems with those sorts of designs. We do not get 100% yield because of manufacturing variances across panels as they're being manufactured. Another challenge, which we always have to consider, is how we're going to test these. There are test fixtures. We have to be able to go ahead and make momentary contacts with the units that have good 50 ohm transitions without soldering the parts down. So that is indeed a challenge. And also, as we're coming through and as we're getting larger and larger sort of circuits, we have to make sure that the CTE of the substrate that the device is made on and the mating PCB that the customer is mounting it to, that those CTEs do balance. If we're talking about a lumped element design, first thing is we have to see how the lumped elements are being attached. These have to go through typically a solder reflow sort of operation. Therefore, we cannot use if we're going to solder the parts down, we cannot use the same solder that our end customer is going to be using to be able to go ahead. Otherwise, we're going to have solder reflow of our parts when they reflow the overall board. So there are things there we need to consider there, whether it's using high temp solder for our parts or moving into an ultrasonic weld to be able to attach those components. Also, there is component staking as these things are now moving up into the next higher assembly. Things like transformers need to be staked so that they can survive the vibration in the next environment. A little bit different than how we would probably stake them if we were going into a full closed housing, but the same sort of idea needs to happen, and that these components do need to be staked. Again, the sealing operations, depending on the package, are again same sort of idea. You want to close up the package. The requirements can be different because now if we're going through a direct solder operation at the next higher assembly, do these have to be able to go through there and be sealed against things like degreasers for soldering operations at the next higher assembly? In which case the level of sealing may be very different and may have to actually be more stringent or better than a separate connectorized component. I will say that there are quite a few advantages to going to a service mount component as opposed to a connectorized component. They do take up less room than a connectorized component. You are eliminating the need for cables interconnecting these things, and you can have a more direct, more compact integration of your overall system of components. So there's a lot of really good advantages to why you want to do this. Just as you're doing it, you have to be careful of all these little trade-offs that are necessary along the way in order to make it happen.
Well, good information as always. Shaun, could you summarize, please?
Certainly. So, there's most components can be made surface mount. There are various things that we need to look at as we're translating the more traditional technology into a surface mount kind of package. There are limitations that we do need to consider, whether or not it is whether or not some of those considerations are strictly manufacturing yield issues, whether we're dealing with going to a slightly different circuit layout, as well as a different packaging layout. You can, however, have a wide variety of different sorts of technologies and still have a surface mount component. You're not limited to any one particular technology. Each one has its own challenges as we're going forward. Also, something else to consider is the size and weight of what you end up with the surface mount component will make a big difference in your overall reliability of what you have going forward, and that is something that we definitely need to make sure of that is something we all consider as we're choosing to go to a surface mount technology.
Excellent. And what are some of Quantic TRM's differentiators?
Sure. So I think the big thing with Quantic is we want to work with our customers to have them have the absolute best solution for their end product and for their customers. We want to go through there and make sure that the products that we build and deliver are really going to be the best ones for the job. Rather than build to spec, we like to go through there, discuss what the needs of the customer are to make sure that really what the customer is asking for really is the best solution. For most solutions, there is typically more than one way to achieve it. We want to make sure that the product that we deliver is indeed the best for the job. In addition to that, we want to make sure that we offer the best overall value to our customer, which is whether or not the customer needs testing to support his design at the next higher value. We're happy to do that. Whether or not it is changing the way that we're building our packaging to make sure that what we end up with is indeed the most robust and most cost-effective package for our customers' needs. And really, we really just like to go through there and make sure that we are a solution provider for our customer. Really, I think that is a big piece. Is we want to work with our customers and we want to solve their problems. And we want to make it as easy for them to use Quantic TRM for all the passive networks going forward.
Well said. And I think we have time for one question, and the one that should come in is, can I use screws to attach a larger surface mount device?
The answer is yes, you absolutely can. The thing to be careful of, though, is what sort of if the device is large enough where you have to screw it down, whether or not the board that you're screwing it to will survive things like vibration. Usually, you get a little that much mass on a PCB that is unsupported. You can very often lead to some vibration failure. So be very careful about that. And really, it's if it gets to be too heavy and you're dealing with this sort of vibration problems, whether or not you want to actually mount it directly to the PCB or whether you want to mount it to a part nearby and cable over to it, not actually use a surface mount, or indeed, do you want to go through there and actually have a threaded a threaded surface mount part that actually sandwiches the surface mount component and the motherboard or directly to the housing, sort of helping to alleviate that sort of trampoline effect that you're going to get with having a heavy object onto a motherboard. So lots of options can be done. We just got to be careful about how it's actually done.
Okay. Well, in conclusion, I think the bullets on your screen really say it all. And going forward, if you are a customer and you have more questions or would like to speak with some of our engineers, please feel free to call our engineering hotline. We'd love to hear from you. The number is on your screen, 888-677-6877. And there's no cost, of course, associated with these conversations. If you're one of our field sales representatives, then, of course, your calls are always welcome. And looking forward, the next Tech Talk will be on Tuesday, July 25th at 1 p.m. Eastern, and the topic will be radial power combination techniques. Thank you all again for joining us, and thank you, Shaun.
Thank you, Paul.